Welcome to 61D, the course where we teach you modern full-stack web development. My name is Aiden, and today we're going to be covering JavaScript. We're going to start with a little bit of an introduction to the JavaScript language before covering basic syntax, arrays, objects, and asynchronous code. All of these different chapters will both be chapters in the video and have timestamps in the description. If it's a lot to digest all at once, I'd highly recommend watching this video in little segments. Before we begin, know that this is not an introductory programming lecture in the sense that we're not going to cover programming concepts at a fundamental level. Instead, we're going to show you how you can implement common programming concepts in JavaScript and cover many JavaScript-specific language features. Also, make sure that you have your computer set up for JavaScript development. All the instructions on how to do this are in the setup assignment we have for the course, which will be linked in the description. And without further ado, let's begin and talk about why you have to learn JavaScript to do web development. The most important reason is that web browsers natively run JavaScript. There's no other language that they run. If you want to control the behavior of your web page and have custom logic, which controls what is displayed to users, what users are allowed to access, and you want any of that to happen within the browser itself, you have to write that within JavaScript. This limitation means that if you want to know full stack, which means both front end and back end, you have to know JavaScript for the front end. And now, if you're already learning JavaScript for the front end, you might as well use it in the back end, especially when you're learning. Unfortunately, modern technologies allow you to run JavaScript outside of a web browser, even if JavaScript wasn't initially developed for this purpose. The tool that allows us to do this is something called NodeJs. NodeJs is a runtime which allows you to execute JavaScript outside of the browser. There are other JavaScript runtimes besides NodeJs. We're going to specifically be using a runtime called Bun because it supports TypeScript natively. But the general idea is that you have a distinction between JavaScript code, which is going to get executed inside of a web browser, and JavaScript code, which is going to get executed outside of a web browser, either locally on your device or in production in some kind of web server. So if you look at sort of the landscape of what you could use to develop a website, on the front end, everything is going to use JavaScript, and on the back end, JavaScript is a solid option, assuming that you don't have high-level performance constraints. Finally, it's important to note that although all of the core JavaScript features can execute both in the browser and in Node.js, there's a few differences to be aware of. To begin with, there's certain operations and certain APIs which are only supported in one environment or the other. For instance, in a web browser, there are web browser specific storage systems such as local storage, session storage, and cookies, and it only ever makes sense to access and manipulate these within a web browser, and therefore the APIs to do so are only implemented in a web browser. Similarly, JavaScript to manipulate the actual HTML and CSS on a web page is normally only implemented in a web browser. Things which require an elevated level of permission and security that you can't normally do in a web browser, such as access the device operating system or do more security sensitive features, normally are only supported in the backend in something like Node.js. And of course, the vast majority of functionality is supported in both. And with that, let's start coding. To start, go to the link in the description to get the starter code. Click on this little dropdown and copy the URL to clone the code locally. Open up whatever your terminal of choice is. In Mac OS, you can just use the default terminal, or on Windows, you should use PowerShell. Navigate to whatever your preferred place to store the starter code is, and just run git clone and paste that link. that will clone the repository. You can change directory into it. So it's lecture JavaScript. And then you can open it up in VS Code. If you have it configured, you can just use the terminal command, or you can open it manually. So let's get going. To start, open up the blank basic.js file. For all lectures, including this one, we'll have both blank files that you can use to code and follow along, and also files with all of the lecture code completely filled out already, so that if you're trying to copy and paste something or take a look at it, you don't have to copy and type out directly what I'm typing on my screen. You also are going to want to open up a new terminal window so that we can actually run our commands. And just make sure that you have bun installed again. You can just write bun. If you get some output like that, then you're all good. Change directory into our blank directory so that then we can run our file. And now we're ready to begin. First order of business is just covering comments. Very similarly to other languages, you can do a single line comment with 2 slashes or a multi-line comment with a slash and an asterisk. Now, for your first program, the first thing you want to do is just log something to the terminal. For that, similarly to how you might write print or system.out in Python and Java respectively, JavaScript, all you do is you say console.log, and then we can put in some string that we want to log with quotation marks, hello world. Save, optional semicolon, and then just write bun basic.js. And there you go, hello world. Next up, declaring variables. There's 2 different keywords you need to know for declaring variables. We have let, so we could say let age equal 21. Let is used for variables which are mutable or can change. So for this variable, we're allowed to say age plus equals 1 to increment it, and then we could afterwards console.log age like so, and then it will show up as 22. However, in many cases, we want to specify that we do not want a variable to change. So for example, we could say const for constant name equals Aiden. And now if I try to reassign this to something else, if I say name equals John, this should throw an error because we're not allowed to reassign a constant. As far as actual types of variables you can declare, we already covered 2. We have numbers and strings. It's also important to note that JavaScript does not make any distinction between things like integers or decimals. So they're just represented as numbers unless you need a very, very large number. And then there is actually a big int type, but that's not relevant for today. And then there's just a few more. You can set something to be a Boolean, which just means true or false. So we can say my bool equals true, or we could also set it to false. False. You can set something to be null. So my null equals null. This is normally if you're trying to deliberately say that something has no value associated with it. But there's also a type which is undefined. This normally means that you're trying to access something that doesn't exist, or you're trying to access some data which hasn't explicitly been set. And it still has no value the same way that null does, but typically it means that it doesn't mean that it deliberately has no value. It just means you're trying to access something that doesn't exist. So we can say my undefined equals undefined. Now we can move on to basic function declaration. The keyword to know for this is simply function. I can make a function, for example, to greet somebody. I can have it take in some argument. So in this case, it's going to be the name of the person we're going to greet, curly brackets, and then I should typically return something. So I can say return hello name. Then what I could do is I could console.log greet Aiden. And then if I get rid of my other console logs so that we're not cluttering up our output and that error, we can run this again, bun basic.js, and we get hello Aiden. Also, interesting thing you can do with console logging is the main situation you would use it. Similar to something like f strings in Python, JavaScript has template strings. So instead of using quotation marks, you instead use backticks, which are to the left of the one and or exclamation point key. And within the backticks, you can do $, curly bracket. And within here, you can put some JavaScript expression and that expression will be evaluated and inserted into the string at that given point. So in this case, I can just put the name that we passed in, run this, and we get a little bit nicer and easier to manage syntax. Now, this is going to be a little bit of a recurring theme. In JavaScript, there are many, many ways to do the same exact thing. I just showed you one way to write a function. If you want, you can always write functions this way. However, a lot of the time you're reading other people's code and not just writing your own code. If you're reading other people's code, you have to understand all the different ways that people can accomplish the same thing because they might choose a different way than you do. There's another very common way of writing functions in JavaScript, which is called arrow function syntax. If we were to rewrite this function with arrow function syntax, what we would say is const, because the actual definition of the function doesn't change, greet arrow. We are setting this constant equal to a function, and we're using equals and then the little greater than sign creates a little arrow saying that this function is going to return whatever this expression is. In this case, we can just put curly brackets and say return hello. And then if we wanted to actually pass in the name, then we could pass it in like so. And then we could console log it. Greet arrow. Name. Oh no, what's the name? We will greet Alice. There we go. So we have hello Aiden, hello Alice. This syntax is actually the most commonly used way of declaring functions, and for a couple good reasons. Mostly, the main reason is that it allows you to write functions much more concisely, and especially when you're passing a function into another function, or you're defining what is called an anonymous function, or just a function that doesn't have its own name. This is just the easiest, most concise way to do it. When you have a function that's a single line, you can also omit these curly brackets and omit the return statement and just say, hey, this function is going to directly evaluate to this, and you don't even need the return statement. The final bit of basic JavaScript syntax we're going to cover is control statements. So, similar to other languages, you have the syntax for an if-else statement. You just have if a certain condition is true, you can do one thing, Otherwise, you do another thing. We could also put in as many else if statements in here if we wanted, if we have more than just a binary, two possible options. The operators, logical operators within JavaScript have the same syntax as most other languages. 2 vertical slashes is or, 2 ampersands is and an exclamation point is the not operator. Also, there's a few values within JavaScript which evaluate to false when being used in some expression like this. Those are an empty string, null, undefined, 0, and the false statement itself. This is important just when you are writing code. You want to make sure that you could have something like an empty string, which could be a valid input, but if you're just evaluating whether or not something is true or false, this would evaluate to false, when really you might say, oh, I actually only want to evaluate something like this if it's null or undefined. And everything else besides that is truthy. So any number, any string, any object will all be a truthy value. Moving on to the actual JavaScript specific thing is the ternary operator, which is just a question mark. Very, very often you'll have a situation like this and you'll want to use fewer than 6 lines of code like we have here, especially when we're talking about front-end development where you might have something within a UI that you want to conditionally render one thing if it's true, another thing if it's false. Sorry, adjust my camera. The way we can do that is with this question mark operator. How it works is you have some condition and then a question mark, and that what you return on true, colon, return on false. So putting that into action, we can refactor this to just be a single line. We can say const is old enough ternary, and then we're going to return the expression based on our condition. Age is greater than or equal to 21, question mark. If it's true, we say welcome stranger, colon. If it's false, we return no youngins allowed, like so. Again, you don't have to choose to ever use this shorthand, but you need to be able to recognize it when you're reading other people's code. So that's just some basic JavaScript syntax. We covered variable declaration, functions, and conditional statements. Next, we're going to move on to talking about arrays. An array is just a list of items. The way you declare it is using brackets. So we can say const names equals Alice, Bob, and Charlie. Right? So now we have our array with 3 items in it. Arrays in JavaScript do not have to have their size defined beforehand, so you could continue appending data to this for as long as you want, and you don't have to worry about it, running out of memory space or anything like that. Arrays are 0 indexed, much like most other languages, so if we want to get Alice, what we could do is we could console.log names, and then to index within the array, we use brackets again and do the position we want to index. So 0 would be Alice, 1 would be Bob, 2 would be Charlie. Another important thing is if you want to get the last element in an array, you can use a built-in function within, or a built-in value within an array, which is just the length of the array. So to get the last item, it's always going to be the length of the array, which in this case is names.length, length. and then subtract 1 so that you don't go out of bounds. So if we go bun arrays.js, you'll get Charlie. One of the most common things that you have to do with an array is you have to loop through all of the items. There's a couple ways you can approach this, and it honestly just comes down to personal preference. The first thing is you can loop through the indexes. So you can say for let index equals 0 while the index is less than names.length, and then increment the index by saying index plus equals 1. And then you could console.log names index, like so, if you wanted to log all of the names. Alice, Bob, Charlie. You can also access the items directly if you don't care about the index. For that, we would say for const name of names, and then we could console.log name, like so, get us the same thing. Or very often we want both. In that case, there's a special function we can call on an array called array.entries, and that's going to basically give us both the index and the item itself so that we don't have to worry about indexing within the array. So for that, you just say const index item of names.entries, and then we could log the index and then the item, like so. Run that, and as you can see, we have index item, index item, index item. Again, personal preference. Now moving on to specific array methods, also known as functions, doing the same, both of those words mean the same thing. Two most basic things you can check is, first, does an array have some value, which will return either true or false. So we could say const has Aiden equals names dot contains, dot includes Aiden. This is going to return false because our names array does not have Aiden. You can also search for the specific index at which some value exists. If you have duplicates, so for example, we had 2 Alices, then it will find the first occurrence, but we could say const Alice position equals names dot index of Alice, and this will return 0 because the first occurrence of Alice, oops, if I lowercased it, then it would. This will return 0 because that's the first occurrence. If there are no occurrences, so for example, I did some kind of misspelling, Alice ASDF, this would return -1, which just implies that it doesn't exist. And yeah. Next off are a lot of functions that you can call an array, which essentially make the process of looping through an array easier. So everything we cover in the next 5 minutes, if you don't really understand it, you can always just loop through an array. First thing we can do is you can filter out items within an array and just get a subset of items. So if you could imagine doing this with a for loop, let's say we wanted to get only the names that are longer than 4 letters. Sorry, Bob. So what we could do is we could say const long names is an empty array, and then we could loop through for const name of names, have our condition say if name.length is greater than 4, then we would add the name to our long names array. We could say long names dot push to add something, the actual name. And here we could console.log long names. And then if we run that, we can comment that out. Oops. Then we get only the long names. However, this syntax is not the best. It's kind of long, kind of verbose, and we can do much, much better. For that, we use the filter function. So we could say const long names filter equals names dot filter. And within the filter function, we have to say, how do we want to filter these values? What we're going to do is we're going to pass a function that takes in the value itself and then returns true if we want to include it, or false if we do not want to include it. So we can say value arrow, and then we want to include it only if value.length is greater than 4. And we can try logging this. Console.log long names filter. And it works much the same. Now what I want to draw your attention to is the fact that this is an arrow function. What we're doing here is we are passing a function into another function. And that's why it's nice to just be able to use this super short, super concise syntax. We could, however, do something different. We could take this very short, concise inline arrow function and write a whole function that we would pass in to the filter function. We could say we'll use the old function filter, we'll call it filter function. We notice that we are taking in a value, so we'll say value, and then we want to return this expression. So we could say return value.length is greater than 4. Then instead of passing in this anonymous function, well, it's called an anonymous function just because it doesn't have a name. It only exists in this one place. We could pass in our filter function and it'll work the exact same way. However, as you can see, this is extremely cumbersome and just ugly to look at. Realistically, we're only going to use this filtering within this one spot, and so therefore this inline syntax is almost always preferred and what you want to go with. Also, with all array functions like filter and more ones that we're going to cover, you can not only get the value of the specific item that you are looking at, but you can also get the index that we're looking at and the array itself. So, for instance, if the condition of whether or not we want to include the filtered array depended also on the index, or we needed to check some other values within the array, we can use this whole, all of that context to determine, whether or not we're gonna, at the end of the day, return true or false right there. The next most common one is the map function. The map function, it is gonna return an array that is the same length as your input array, whereas filter is going to be either the same length or shorter. However, it's going to transform the data. So for instance, let's say that, our names, we wanted to include the index within the name such that we could print it very nicely. We could say const names with index equals names dot map. And here we're going to need both the value and the index. So we can get the value, index, arrow syntax, and what we're going to return is a string where we're going to say index colon value. So this transforms the data. It's also important to note that here we're just working with strings, but you can return whatever data type you want here. You don't have to map a string to a string. You could map a string to some other complex object, to a number, to whatever you want. So let's just show this off. Console.log names with index. And we can run that. So there we go. So now we have this string where we have the index and the value. There's several more of these, but there's only 2 more we're going to cover today because many of them are not actually that useful. The next one is the .every function, and then also the .sum function. Basically, both of them you pass in a condition, and .every checks whether or not that condition is true for every single element within the array, and .sum checks that that condition is true for at least one element within the array. And then both of them, depending on whether every element or only one of the elements pass the condition, will evaluate to either true or false. So what we could do is we could say all names long, and we would check if every name, or we'll just say current name, if every current name has a length of greater than 4. This is going to return false because we have Bob, which has a length of 3. But if we didn't want to check if all the names are long, we just wanted to say some of the names are long, then we could change this to .sum, and this will return true. Next up is more complicated indexing, also known as slicing. Before, all we did is we got a single individual element at an individual index, but there's many cases in which you would want to get a range of indexes. The function that we use for this is the .slice function. It works similarly to how you can index arrays within Python. You pass in a start and an end. The start is inclusive and the end index is exclusive. You can optionally also pass in no end index to just get from that starting index to the rest of the array. So if we wanted to get indexes 2 through 4 for some numbers, we would say const 2 through 4 equals some numbers dot slice, right? So we pass in the start and the end. Since we want indexes 0, 1, 2, 3, and 4, we say we start at 2 and we end at 5. The reason we say 5 is because this first 2 is going to be included, 3, 4, 5 is going to be excluded, but 4 will be. So then we can console.log this, console log 2 through 4. Comment that out and log, and there we go. We get indexes 2 through 4, which in this case is 5, 8, and 22. And again, if we just wanted to onward, we could just do that, and then we get 5 through to the rest of the array, like so. However, our current slice function doesn't necessarily help us too much if we want to get some more complicated range of numbers. For instance, if we wanted to implement a function all but index, which gets an array and a specific index that we want to exclude, it might not be super easy to do this in a nice and concise way. What we could do is we could get the first half as array.slice from 0 to the index, and then we could get the second half, which would be array.slice from 0 to starting at the index plus 1 and then going out to the whole rest of the array. But this has, 2 arrays, and we need some way to combine them without having them be nested. If we were to return first half, second half, this would have an array with 2 nested arrays. There are functions that you can use to flatten this. However, the sort of most elegant preferred way in TypeScript is to use what is called the spread operator. What the spread operator does is it takes, in this case, an array, but also later we'll show how you can use it with objects, and it expands it into the parent. So the way you can do that is you say ... These 3 dots are the spread operator, like so, and this will just have one array with these 2 arrays expanded within it, such that they're not nested. So if we did console.log, all but index for some numbers, and maybe we want to get rid of index 2, then we could run it like so, and we get rid of that 5. Again, similarly to the thing I've been saying over and over again, it doesn't matter if you don't want to use this spread operator. You have to recognize what it is doing when you're looking at other people's code. All right, now with everything that you have learned about arrays, you know enough that you can complete this first challenge, which is, given 2 arrays, return an array with elements that are in both arrays. You can do this more efficiently with sets, but don't worry about that for now. Just assuming you have 2 arrays, how could you just get the items that are included in both? Keep in mind, if you're using some of the array functions we talked about earlier, you can accomplish this in a single line. However, if you're a little stuck, I'd recommend first using a loop and then seeing if you can shorten the code afterwards. Wait 1 second and pause the video if you want to complete it yourself, and then I will show you how it's done. So we're going to need to use 2 of the functions we talked about. First is this .filter function, and second is the .includes function. All we need to do is say in both can be our name of our function, given array1 and array2. All we need to do is filter out something from either array1 or filter out from array2. So array1.filter, and we want to, given a value, return true if array2 includes that value. So that is your solution. We can check it by console logging and using our 2 arrays. So we say in both some numbers other numbers. And give that a shot. Perfect. So we can check it. 3 is in both, 5 is in both, 8 is in both, and so is 34. Numbers like 7 and 9 are not. Great. That is the basics of JavaScript arrays. Next, we'll be covering objects. An object in JavaScript is anything that takes a specific key and maps it to a specific value. If you're familiar with dictionaries in Python, it's the same thing. The way we can declare an object is we can say const person equals curly brackets, and then we have to give a key. So in this case, we could say name, colon, and then give a value. So name, we could say, is Alice. Then if we want to access that name, we can console.log person.name. Run this, run objects.js, and we get Alice. So this is representing different types of data than you would in an array. It's just, a very flexible structure, and it's used all over the place within JavaScript. The keys and values can be anything. They don't just have to be strings. So for instance, we could have age could map to a number, and you could even map to more complicated nested objects, which we will get to in a bit. It's typical that you'll have all of your keys be camel case. However, it is possible to have any string as a key. If I wanted to have a favorite color as a key, that could map to red. And then if I have some string that has spaces in it, I can access it by saying console.log person favorite color. And we can get Alice and red. However, this is never something you want to do, so just don't do it. Just do like that. Much better. And then you say person dot favorite color. Also, it's important to note that even though you declare an object as a constant, all that means is it's referring to the same actual data structure. We couldn't reassign this to some other object or to a number, but we can add keys to it after the fact. So what we could say is we could say person dot height equals 170 centimeters or something like that, and then get that value, say console.log person dot height, and we can then run this. There we go. So we get our 170. Normally you don't want to do this. Normally you want to define all of the keys you're going to have at the start. However, it is something that you can do if need be. As mentioned earlier, you can also nest objects within other objects, and you can nest arrays within objects. For example, we could have a more complicated student object. Student, they could have a name, so could be Bob, and then they could have, we'll just say demographics, which could be an object within itself. They could have I don't know, a race, could be Hispanic, and then they could have a sex, which could be male or something like that. And you can also map to arrays, so you could have classes equals art, math, and history, something like that. Then if we are accessing this nested object, all we would have to do is we could say student dot demographics dot sex. So we could console.log this. Right, and then that would be male, is what it would say. There we go. Also, you know, if we were going to do an array access, right, similar to before, we could just say student dot classes 0, and this would say art. Another important thing is that this is not the only way to access values within an object. You can imagine that what we could have is we could have multiple students. So we could say student 1, student 2, just rename this Charlie. And it might get a little bit cumbersome to say, okay, student1.name, student2.name. Instead, what we can do is you could say const name equals student1. And this will give you the name property from student1, such that later, if you're trying to write some code using this name, you can just console.log name instead of having to say console.log student1.name. Right, so can do that. Right, we've got Bob and Bob. Final point here, as you can imagine, if we have multiple objects of similar structure, they might have some overlapping key names, and we can't have two constants with the same, you know, we need to differentiate these somehow. So we can't just say const name equals student2, because then we're gonna have name and name. What you can do is you can destructure the name property, that's what this is called, and then rename it once it is destructured. So we could rename it name1, destructure name, and then name it name2, like so. And we could log these. Name1, name2. And we've got Bob and Charlie. So far, we've been accessing properties of objects, assuming that they're going to be defined. If we just have a simple object that is declared for us right in front of us, it's easy to see, oh, if we access the name, that's just going to give us a defined value. If we access the favorite color, that's going to give us a defined value. But that's not always the case. Here we have 3 students, student 1, 2, and 3, and we want to implement a function which gets the sex of the student. This is going to work fine on student 1 because we have the demographics property defined and the sex property defined, but it's going to error on student 2, which doesn't have demographics defined, and it's going to error on student 3, which is just undefined altogether. So we can run it, run objects.js, and see this, right? Undefined is not an object when evaluating student.demographics, or evaluating student.demographics.sex. So how can we handle this? Basically, what we need to do is we need to, before we access .sex, we need to make sure that student.demographics is defined. We can do this with something called short circuiting, which basically says that if you have an AND statement, which requires, you know, 2 things to be true. It requires the first statement to be true and the second statement to be true. if the first statement is false, it's not even going to bother evaluating the second statement. So what we can do is we can say return student.demographics and student.demographics.sex. What this is going to do is first it's going to evaluate student.demographics. If that is defined, then it will evaluate student.demographics.sex and return that. Otherwise, it's going to short circuit and just return student.demographics before it tries to access the undefined property. So if we don't have this undefined case and we try this, it'll work. It'll say male and then undefined. And this is fine, but as you can imagine, if we want this to work in all cases, student and student.demographics and student.demographics.sex, so that it'll work for the undefined student. This is kind of long, and we don't want to have to write this out every single time. Fortunately, there is something we can do called optional chaining. It does this exact thing we just demonstrated, except with a nice little shorthand. All we have to do is say student question mark dot demographics question mark dot sex, and it'll work the same way. What this does is it mimics that short-circuiting behavior, so that if student is not defined, rather than erroring, it's just going to return undefined for the whole access instead of trying to access the property on the undefined object. Now you might be wondering, okay, but what if I don't want to say undefined? What if I want to evaluate something else in the case of sex being not defined? What if I want to have this behavior? I could say const sex equals this thing we just said, and then say if sex is not equal to undefined, return sex, otherwise return unknown. Unknown. Right, and this will make it such that all of our responses are strings. We've got male, unknown, and unknown. This is also a little bit long and cumbersome. You can imagine you might have to do this a million times in your code base, and if it's 4 lines every single time, that's not going to be very much fun. That's where the Nullish Coalescing operator comes in. For that, all you need to do is question mark, and that says, hey, if the left side of this expression is null or undefined, then we're going to return the right side. Otherwise, we're going to stick with returning the left side. So we go like that, and it works like so. You may be thinking, well, couldn't we just use an OR operator here? Since undefined is falsy, it would evaluate to unknown, but that's not very good practice, because if this is an empty string, it will still evaluate to false instead of getting the behavior we want. So for instance, let's say we set sex to an empty string and use the OR operator. We're going to get 3 unknowns, whereas question mark is going to properly say, hey, this empty string is an actual value. It's not null or undefined. So you don't actually see it, but that's our empty string. You could also set it to 0 is another falsy value. And I don't know how somebody would have a sex of 0, but you see that we get the behavior we're looking for. One common final thing we're going to cover with objects is the situation where you have to combine objects. We already talked about destructuring objects, so this is kind of the reverse. Instead of taking pieces out of an object, let's say we have multiple objects that we want to merge into some bigger object. Here we have attacking stats and defensive stats, and we want to create some combined full statistics that includes all of them. This approach works, but it's just a pain to do, and it's also bad because it's not very maintainable. If I were to add something to my attacking stats, if I were to add turnovers as a stat, I would have to change this as well, make sure that I remember to add turnovers, not turnover. I'd make sure I'd have to add turnovers equals attacking stats dot turnovers to each situation in which I am adding this turnovers stat from the entire attacking stats object. Fortunately, we can go back to the spread operator that we talked about in arrays. What we can do is we can delete all of this and say, hey, we're going to spread out the properties of attacking stats, and we're going to spread out the properties of defensive stats. And then this full stats will have all of our attacking stats and all of our defensive stats. And so if we were to add something else, I'm running out of basketball stats, but maybe we'll say field goal percentage as 0.55. It's already in our full stats because we are spreading out all of the properties of our attacking stats. Now you might wonder, okay, but what if I want to have all of the attacking stats except for one, right? Let's say I wanted to override my field goal percentage and change it because I'm changing the way I'm calculating it or something. What you can do is you can actually add the property back later. Field goal percentage equals 45, no, not 45, 0.45. And what this will do is this will override the property that you previously destructured. This is basically like saying, okay, first I'm going to have my full stats, and then I'm going to say full stats dot field goal percentage equals 0.45, right? Except we don't need to do that. We can just do it inside the declaration. That also is important to realize in case you might have overlapping keys when you're doing this destructuring operation. Let's say somehow you have a defensive field goal percentage. Maybe it's the field goal percentage that other attackers have on you. So yeah, we could say field goal percentage here equals 0.45. Here, the order in which we're doing this actually matters. If we destructure attacking stats first and then defensive stats, then this defensive stats field goal percentage will override the attacking stats. And we could do it the opposite way if we want attacking stats to override the field goal percentage from defensive stats. So we can console.log this, our full stats object, see what we get. And we have it here. As you can see, it's using the attacking stats because it overrides it because it came second. Taking everything that we have learned about objects, you're ready for our next mini little challenge. Given an object representing an athlete, so we've got two athletes here, write a function which returns the object with the isInjured property set to false and the sport property set to unknown, only if the properties do not exist already within the object. So in this case, we don't want to override isInjured since this is already true, but we do want to set sport to unknown. And similarly here, we don't want to override soccer, but we do want to set isInjured to false, so that we make sure all of our athletes have the various properties defined. I'll wait 1 second, and you can pause the video to try it out yourself before going over the solution. So the first kind of way you could go about this is you have your function, so we could say update athlete takes in an athlete, I can't spell, takes in an athlete, and we first check, say, hey, if athlete dot isInjured is undefined, then we set athlete dot isInjured to false, and then we do the same thing with our sport property. So we say if athlete dot sport undefined, then we set athlete dot sport to unknown before returning the athlete. A better way is to use what we just talked about with overriding object properties. Basically, what we want to do is say, hey, first we'll set isInjured to false, and we'll set the sport to unknown, but later, if the properties were already defined in the object, they'll overwrite those properties. Otherwise, they'll remain what we set them to. So we can actually do this in a single line. We can say update athlete 2, or I'll just say update athlete better takes our athlete, and what we are going to do is we are going to return, actually we don't even need this. We can just say, hey, we're going to return an object, right, that has the sport property as unknown, the isInjured property as false, and then destructure the rest of the properties of the athlete. So there, if we essentially say, hey, we're going to return an object, it's going to have the sport property, the isInjured property, and the rest of the properties of the athlete. Depending on whether or not the athlete already had those defined, they'll either be overridden or they'll remain the same. So let's try this out. We can say console.log update athlete for athlete 1, and then also for athlete 2. Comment that out. Right, and then we get all of our properties set, and then we can also do update athlete better, and we have all of our properties set. So there, that is the solution to the challenge. The last thing we're going to be covering is asynchronous JavaScript. So far, the only limiting factor to how quickly all the code that we've been writing can execute is just how fast our processor is. If we wanted to calculate 1,000 prime numbers, right, the only limitation would be how quickly our processor can process all that code. But in the real world, the limiting factor for how quickly your code can execute is very often going to be how quickly something can travel over the internet, not how quickly it can be processed once you get it. For instance, you can imagine if we were fetching a bunch of data from our database, it might only take us, half a millisecond to process it, but it might take several milliseconds for that data to get to our machine from wherever our database is. So don't worry about how these functions work, but here I have written two functions which return the base experience of Pikachu and Charizard from an external API. What would happen if I try and just log this experience? Get base Pikachu XP, and we can also just log get Charizard XP. Get Charizard base XP. Say bun async.js. And this is what we get. We get two promises that say they're pending. So what does this mean? What this means is all we have said is we want to get the result of this get base Pikachu XP. But JavaScript does not want to immediately assume that we want to stop everything we're doing and wait for the result before doing something with it. For instance, right, we might want to start fetching both of these, start fetching the Pikachu base XP and the Charizard XP, and let those both, let both of those requests go through before we need to do anything with them. If we want to take this asynchronous code, which is going to go over the internet, it's going to take some time before we get the results back, and we want to say, hey, JavaScript, I want you to stop what you're doing and wait until we have the actual result. What we need to do is we need to use the await keyword. Await. And you know that you will need to use await on a function if it's marked as an async function. So now I can run this, and it's going to take a second because I added an artificial delay, but then we actually wait for the value, right? You can also get a little bit of IntelliSense from your, from VS Code. So we can say const Pikachu promise equals get Pikachu base XP. This is going to be a promise type, which is going to return something from that promise. And then we can say the actual XP, actual XP value equals await Pikachu promise. And now it's not going to be wrapped in a promise, it's just going to have that actual value. And then we could log it and wait for that to go, and we get our value. So you can already see the situation where it makes sense that sometimes we don't want to immediately await the value of a promise. Very often you're going to start a function and you're going to need, 3 different database calls or 3 different pieces of data to actually process the thing you're trying to process. It doesn't make sense to sequentially say, hey, get the first piece of data, wait until I have the first piece of data. Get the second piece of data, wait until I have the second piece of data. Get the third piece of data, wait until I have the third piece of data. Instead, it makes more sense to say, hey, get me pieces 1, 2, and 3 of data, and then wait until I have all 3 of them, and then I can do my processing. So we can actually see what this looks like, right? Before we had, we were first awaiting the Pikachu base XP and then awaiting the Charizard base XP, right? But what we can do is we can say const Pikachu promise equals get Pikachu base XP, const Charizard promise equals get Charizard base XP, and then say, hey, await Pikachu promise, await Charizard promise. So pay attention to when the things are logged. Wait, wait, wait. Now we have both pieces of data, right? They take about the same amount of time, so it makes much more sense. It's about twice as quick to say, hey, here is all the information that we need, and then once we're actually trying to process it, then we await it and go on to then use the information. Key syntax to remember is any function that is marked with async will return data wrapped in a promise. It means that, hey, it doesn't matter how fast your computer is, there's going to be some external thing, some external fetch that we're going to have to wait for. And then when you actually want that information, when you want to say, hey, stop executing code because I need this information before I can go any further, you say await whatever that result is. The other thing that goes hand in hand with asynchronous code is error handling. Most of the time when all of the code execution is on your own machine and you don't have to worry about some network connection or some external service, you can normally predict when you're likely to have to encounter errors, how you're going to have to handle them. But anytime you're dealing with some external API, you have to properly handle errors. For instance, if I were to not execute, change anything about the code, and just turn my Wi-Fi off, and if I were to try and run this, I'm going to get an error, right? Either there was a typo in the URL or it couldn't establish the connection, and this is not going to work how I want. For this, you use something called a try-catch statement. Try-catch statement just says, hey, here's some code that I want to attempt to execute, and then if any error is thrown, here's the code I'll execute instead. All you do is you say try, and then you can wrap whatever you want to try. Oops. And then you say, catch, you'll get some error object, and you can do something with it, right? You can console.log your error. And then we can live to code another day, say, hey, this will still execute. We actually only need one of these, and what we expect is that we will run into an error because we have no Wi-Fi, and then log the error, and then continue to execute the rest of our program. So if we run that, we say there was an error, this was the error, and then this will still execute. Then if we were to delete this try-catch, and try and make sure that we have this will still execute running, we won't get there because it will error beforehand. We actually only need one of these, and what we expect is that we will run into an error because we have no Wi-Fi, and then log the error, and then continue to execute the rest of our program. So if we run that, we say there was an error, this was the error, and then this will still execute. Then if we were to delete this try-catch, try and make sure that we have this will still execute running. We won't get there because it will error beforehand. One final useful bit of syntax before our final challenge is if you have a lot of promises, perhaps they're all in an array, and you need to await all of them at once, there's some nice syntax you can do for that. So what we could do is we could refactor this, say const Pokemon promises equals an array which has get Pikachu XP and also get Charizard XP. And let's say I wanted to await both of the promises and then sum them. I could say const Pokemon values equals await promise dot all, and then we pass in that array. This is going to have our two values at the 0th and 1st index of the array. And then if we wanted to console.log, we could say the total XP is Pokemon values 0 plus Pokemon values 1. And if I reconnect to the internet and run this, we will get our total XP and this will still execute. Now we're ready for final challenge of the video, which is write an async function that takes a name of a Pokemon and returns the base experience. If the Pokemon is not found, return Pokemon not found. So for this, you can copy this internal code from these functions and just refactor it such that instead of saying Charizard, it's the actual Pokemon name. And a little hint is that if the Pokemon is not found, then this little segment of code will throw an error. So you can wrap it in a try-catch statement to handle the case where the Pokemon is not found and return Pokemon not found. Give you a second to pause the video and try it yourself, and then we'll do it. So what we can do is we can say const get Pokemon XP, takes a name, we'll say a Pokemon name. Then we can paste that code segment. You'll notice, right, it's bugging us because we need to make sure that we specify that since we're using asynchronous code, we need to mark this function as asynchronous. All we need to do is, instead of passing in Charizard, rewrite this so that it takes the Pokemon name and that will return the experience like we want. We can test this out, say console.log get Pokemon XP for Eevee. Sorry for the dogs in the background. Run this. Oh, gotta await it. 65, but this doesn't handle errors. So to make it handle the error properly, we need to wrap it in a try catch statement and return Pokemon not found. then even if we have bad spelling, we will not error. We will simply say Pokemon not found. And there you go. That is your crash course on basic JavaScript concepts. As a reminder, all of the completed lecture code, it might not be 100% the same as what I wrote, but all of the examples are in the completed folder, and we have the blank folder for you to follow along, which hopefully you are doing. Next week, we're going to cover TypeScript, which adds functionality on top of JavaScript to make it much, much easier to write and maintain. See you then.